Have you ever noticed how the conventional lab on a chips, like this one shown, has two wells that converge into one? These two wells contain fluids that would most likely mix in this microfluidic phenomena. Now, how would the mixing occur? Now, we questioned how this would occur by doing an experiment using conventional household items. Since fluid mixing in laminar flow is basically driven by diffusion, the length required to mix two fluids can be simply defined by this equation, where U is the streamwise velocity, D is the diffusion coefficient, and R is the radius of the channel. With this, we hypothesize that under the same velocity and diffusion coefficient, the larger R the channel has, the longer length is needed to mix fluids in channel. If you want to shorten the mixing length for the larger tubing, turbulence should be included in the flow field. To test our hypothesis, we used the two smaller straws to syringe the two fluids, the blue water and the yellow water, for mixing. We released the fluids at the same time using gravity as our mode for velocity, and observed the fluid when it met at the bottom of the apparatus. As you can tell from this video, we noticed that the fluids mixed right away. For another experiment, we used a 12 millimeter straw that's cut in half, and we also noticed that the fluids mixed instantaneously. In failing to prove our hypothesis with our experiment, we recognized some faults in our experiment. Even though we are testing for laminar mixing, our experiment most likely had turbulence within the flow. As there's little to no delay between mixing in the apparatus, we acknowledge that our experiment is flawed. Also, the use of water as our primary fluid in our experiment was another factor for error. Water is a low viscous fluid, and it will be hard to determine the time it takes for the fluid to mix if we combine a low viscous fluid and a standard speed camera.